All right, welcome to the night class. Today we're going to be applying our trigonometric functions to problem solving, basically. We're going to be finding some missing sides. Only doing the missing sides today. We will get to missing angles another day. So, here, simple triangle. If you want to redraw your triangle every time, you can. You do not have to. I'm going to draw them up here and then erase, because I have technology to do that. So whatever you want to do. Number 5, or example 5, whatever you want to call it, it gives us B. It says B is what? 13. And it tells me angle A is 76 degrees. And we have to find angle A. So we ask ourselves, what's opposite angle 76 degrees? A. And B is the what? Which side? Adjacent. So we're looking for the opposite. They give us the adjacent. What trig function uses opposite and adjacent? And that's when you say, okay, so, ka, to. Which one is using the opposite and the adjacent? Tangent. So we're going to say, for number 5, the tangent of 76 degrees equals, you always take sine, cosine, and tangent of the angles, okay? So tangent of 76 degrees equals what? What is opposite 76? A divided by the adjacent side is B, which is 13. And then you solve it. So what do you do to solve that for A?
Times it by the reciprocal.
Multiply by 13 on both sides. When you multiply this side by 13, they cancel. 13 times tangent of 76. At this point, you grab your calculator and you type it in. Okay. Make sure your degree mode is set on your calculator. So you go to mode, make sure the degree is highlighted before you start working these problems. And that goes for your calculator that you're using in class, or if you have a calculator on your phone. A lot of you have the Desmos calculator. Make sure it's in degrees as well. All right. What do you get when you put that in your calculator?
52.14.
It says round to the nearest tenth, so we're just going to say 52.1. And that's all there is to today. That makes sense? Okay. Number 6, I'll just come over here. Again, I like writing them up here so I can see. All right. I would recommend drawing 3 triangles every time, and okay, or draw something just so you can see. It does help. They give me angle B is 26 degrees. Side B is 18, and this time I'm looking for side C. So what sides have they given me? Opposite and hypotenuse. What up here uses opposite and hypotenuse? Sine. So sine of the angle, which is 26 degrees, equals opposite is 18 over the hypotenuse is C. Okay? C is in my denominator. However, though, this is a proportion. Okay? I used the example earlier. 3 over 6 equals 4 over 8. Is that true?
Yes, sir.
That is a proportion. Since it's a proportion, I can move things diagonally as much as I want. Okay? I could switch the 8 and the 3. Is that still true?
Mm-hmm.
Yes. I could switch the 4 and the 6. So 3 over 4 is the same as 6 over 8. You follow me? As long as I'm moving diagonal, it's okay. I could just move, say, the 8. What's 3 times 8? 24. 24 divided by 6 is 4. Okay, everything still works. This is also a proportion. I just don't write the over 1 part. Is everybody understanding that? So I can replace this C with sine of 26 and move the C where the sine of 26 is. Okay? So this is just going to be C equals 18 divided by the sine of 26 degrees. And then you just put that in your calculator.
41.1.
Coach,
Yes.
Just say that could you swap the 18 and the 1 and it still be true?
I could swap the 18 and the 1.
And it still would be true?
Sine of 26 over 18 would equal 1 over c. Yes,
Yes, sir.
sure would. You won't ever need to do that, but yes,
Yes, sir.
that is true. Okay? C times sine of 26 equals 18. All right? Any of those are the same. All right, last one. Number 7. 7, make sure you know how to use your calculator correctly. B is 16 degrees, 45 minutes. Angle B, I should say. Side C, or the hypotenuse, is 13, and I'm looking for side A. So, side A is what to that angle? Adjacent, opposite, hypotenuse. Which one?
Adjacent.
It is adjacent, and C is the hypotenuse. So what uses adjacent and hypotenuse? Cosine. So this time we're going to do cosine. Cosine of 16 degrees, 45 minutes. I don't know why I put another degree sign there, sorry. That's going to equal, adjacent is what? A over the hypotenuse is 13, so we multiply both sides by 13. A equals 13 times the cosine of 16 degrees, 45 minutes. Does everybody know how to put the 45 minutes in your calculator? Okay. If for some reason you don't have the minutes on your calculator, you would need to change that to a decimal. Okay.
So just put 16 times 45 minutes.
Actually, you'd say 16 plus what? 45 over 60. Because this is telling you how many minutes there are, and there's 60 minutes in 1 degree. So this is 45 out of that 60.
So it would be 12.4?
For the answer, I believe so. Yes. 12.4 in your answer. Okay? Any questions on those 3? We're going to do 2 more examples. They're more word problem-y, but it's basically doing the same thing. Okay? Everybody good on 5, 6, 7? Wonderful. Number 8. We have a little vocab that we need to be familiar with. It says each base angle of an isosceles triangle measures 55 degrees, 30 minutes. So, if you don't know what a base angle is and you don't know what an isosceles triangle is, we're already lost, okay? So, first off, isosceles triangle. What is an isosceles triangle? Triangle with 2 sides that are the same. So, I'm just going to draw a regular old triangle with 2 sides as close to being the same as I can draw, okay? It says the base angle is what? 55 degrees, 30 minutes. Which angles are the base angles?
One that's not.
The ones that, where are they?
Bottom.
They're at the bottom, they're at the base, okay? So this is 55 degrees, 30 minutes, and this one is also 55 degrees and 30 minutes, okay? Anybody remember what that top angle is called? The vertex angle. Very good, okay? That is the vertex angle. All right. It says each of the congruent sides is how long? 10. So I'm going to label these as 10 centimeters. I didn't measure them, but they told me they were 10 centimeters, so we're going to assume they're 10 centimeters. Everybody good so far? All right, 3-part question. Part A, find the what? What is the altitude fancy for? Fancy name for what? The height of the triangle. So I'm going to draw my height. When I do that, what did I just have to make down here? I had to go make a right angle, otherwise it is not the height. Does everybody understand that? Okay? So basically I just cut that triangle in half, right? And I'm looking for A there. Now A stands for altitude and A stands for, it's part A we're doing. All right? And now forget about the whole triangle, just worry about half of it, because half of it's a right triangle, and we can do our sine, cosine, and tangent. Everybody with me? So now it's back to doing like we just did. So we have this angle. A is what to that angle? Opposite, and 10 is the hypotenuse. So what uses opposite and hypotenuse? Which trig function are we going to sine? So we're going to say the sine of 55 degrees, 30 minutes is going to equal the opposite side, which is A, divided by the hypotenuse, which is 10.
Wait,
How do we work that?
Multiply by 10.
Multiply both sides by 10. Do you have a question?
yeah, I was drawing it, so I didn't really get the A part. How did you know that it was A?
That's the altitude.
Oh, I thought you were doing like with the angles, how the big A across from the nose.
No, it's just the altitude. All right, what is 10 times the sine of 55 degrees, 30 minutes? 8.2, the people say. All right, for part B says, what is the length of the base? So they want to know, how far is it from here to here? Can we get the whole thing with our triangle?
Can't you just do Pythagorean Theorem?
You can, but that would only be what?
One of them?
That would only be half.
You multiply by
You can get from here to here, and then you just do what to that?
multiply by 2.
Multiply it by 2. Okay, so you can also, she said Pythagorean Theorem. Yes. The problem with doing the Pythagorean Theorem is we would have to use A, and what did we do to A's answer? We round it. So if at any way possible you can do problems without using something that you rounded, you need to. Okay, so I'm not saying you're wrong. I'm just going to say you're going to throw the answer off more. Okay, and you'll see in part C where we have to find the area of the triangle. Well, to find the area, it's 1/2 the altitude times the base, right? The height times the base. We're going to have to use our rounded answers. We don't have a choice. You follow me? But for part B, we have a choice. Okay, so rather than doing the Pythagorean Theorem, which again would work, I want to figure out, I'll just call this x, okay? I want to figure out x. X is adjacent to my angle, and then I have the hypotenuse. So what uses adjacent and hypotenuse? Cosine. And I don't have to use that side that I've rounded. Does that make sense? All right. So we have cosine of 55 degrees, 30 minutes will equal to x over 10. And we just multiply both sides by 10 one more time. They will cancel out. What is 10 times the cosine of 55 degrees, 30 minutes?
Seven.
5.7?
Because it's 5.6.
I was about to say, same reason here. I don't really want to round here, okay? Now, so just give me the whole decimal. 5 point what?
5.664062369.
Gracious. Okay. Now, does everybody understand why I don't want to round here? Because what do I still have to do to that?
Oh, find the area.
Not yet. See, I just found this part. What do I still have to do? I got to multiply that by 2. So just put times 2 in your calculator, and you'll get your base.
Then round it?
Then round it. Yeah, then round it. So that would be 11 point what? 11.3. Okay? Does everybody understand why? If you put 5.7 in your calculator and multiply that by 2, I think you get 11.4. So we're off a little bit. And then we're going to use it again, so we're going to be off a little more. Okay? So always try not to round until your final answer. Okay? Part C, we already kind of briefly talked about it. Area of a triangle is 1/2 the base times the height. All right, so that's going to be 1/2. The base we just found was 11.3, and the height we found was 8.2. Again, I don't like using rounded answers, but this problem leaves me no choice. Okay, I have to. So what do you get there? 46.33. And since it's area, and we were doing centimeters, it is square centimeters. That means 46.33 little square centimeters. Little centimeters about little squares about that big could fit in it. Okay. Any questions? Awesome. All right, last example. We got a lighthouse. I get to draw. They made fun of my drawing in first block, so I'll try to do better this time. A lighthouse. It's not.
Need Coach Glover to come by. Coach Glover, he's got some good stick figures. Yeah.
It makes it all big.
Yeah, it looks like a chess piece.
Oh, yeah.
Looks like a very radiant chess piece. Looks like a gumball machine.
It looks like a gear shifter.
Coach, I think it looks like a lighthouse.
Thank you, Clayton.
Why the top?
Coach Glover would do it better.
Hit with much.
Everybody loves Coach Glover, okay? I get it.
I'd rather have it size.
All right. Thank you, thank you. They tried to say it looked like a birthday count first block, but anyway, all right, so
It's a cute birthday.
thank you, thank you. All right,
Yes, it does.
how tall did they say my lighthouse was?
I don't know.
170.
It says it rises 175 feet. And say we got Ponce de Leon, or in good old country fashion, Ponce de Leon. All right, it's the lighthouse in St. Augustine, and y'all know St. Augustine, Florida. He landed there. Y'all knew that? Okay, all right. It's the second tallest brick tower in the United States. I did not know that. It was built in 1887. Like we said, it rises 175 feet above the ground, or above sea level. How far from the shore is a motorboat? They made fun of my motorboat too, but oh well. Okay, it's got a little little top to it, you know. Guy right here. That's his little steering wheel. Is that bad? That's not too bad, huh? That's not bad. All right. We make our triangle out of this. Of course, it's a right triangle. That's a really bad triangle. Whoa, I didn't mean to take the whole thing off. That's a little better. Okay, so it says how far from the shore is the motorboat. So here's the shore, here's the motorboat. I'm going to label that X. If the angle of depression from the top of the lighthouse is 13 degrees, 15 minutes. Okay, so first off, depression means you're looking what?
Down.
Down. Okay, depressed means you're down, you feel bad. Okay, so there is a horizon up here. Okay, this is the 13 degree, 15 minutes angle of depression. It's right there. Okay, not here. You follow me? What's the other type of angle that we talk about? Not depression, but what? When you're looking up. Elevation. So the angle of depression and the angle of elevation are always equal, okay? And here's why. You see this horizon line right here? The ground, or sea level, and it will always be parallel. And from geometry, we have a transversal. Do y'all remember that word? Okay, transversal cuts the parallel lines, and you have, what are these?
Alternate interior.
Oh, I'm so impressed. Alternate interior angles are the same, congruent, okay? When the lines are parallel. If the lines aren't parallel, they're not. But these are parallel, so this is also 13 degrees, 15 minutes, okay? Now, what's another way we could have done it? What could we have done to find this angle? We could have said 90 minus 13 degrees, 15 minutes. Sure could have, okay? And then we'd have been working with this angle. But to me, it's just easier just to move your angle. Everybody good with what I did?
Yes, sir.
Awesome. We have the opposite side, and we're looking for the adjacent side. So what trig? We're doing tan. Tangent function, tangent of 13 degrees, 15 minutes. I did it again. Keep doing the minute sign as a degree sign. 15 minutes equals, opposite is 175 feet over x. What can I do with x and the tangent? I can just switch them. So x will equal 175 divided by the tangent of 13 degrees, 15 minutes. Stick that in my calculator, and I should get 743.2 feet. And of course that is rounded. Okay? Any questions? Everybody's good? Awesome. Awesome. All right. Hope everyone out there does great. Have a great time and see you next time and stay above the line. Man, that's a